Hi, Andrew.
Hi,
How are you doing?
good.
Thank you for taking time out of, your weekend and coming here.
Of course. Yeah, no worries.
We can just give people maybe a couple minutes to join in.
Yeah, sure. Can you guys see my screen? Cool.
It's perfect. And you're still able to see the Hopin website, right?
Um, I might not be able to see it when I'm doing my presentation. Do
Okay.
I need to
No,
or
no, no, no. I'll be here to check on questions and stuff, and I can let you know if there's anything.
perfect?
So we can go ahead and get started. Um, So Andrew Chen is a mobile developer who loves to teach and learn. He went to college not knowing what he wanted to do and ended up majoring in electrical engineering. After graduation, he realized he didn't love the subject and took some time to figure things out. Andrew traveled for a while, and when he came back, decided to work on an iOS app with a friend over the summer. He didn't know a lot of programming at the time, but all he really needed was a laptop and Google. This was rewarding enough to keep him working on it through the summer. It wasn't a very good app, but the experience not only led him to go back to school for computer science, but it also led him to an internship at Twitter, where he was very fortunate to work with some amazing engineers. This internship really solidified the idea of mobile development as a rewarding career choice. After that, he finished up school and went on to work full time at Twitter for a few years and is now at Google working on a maps related product. I just love that story so much. Thank you so much
um,
for coming and joining us, and hopefully, we'll be able to make some cool apps.
yeah, thank you for the introduction. My name is Andrew. Um, Yeah, the format for today, I'm going to do like a quick intro to iOS and like the Swift programming language in general, and then we will run through a simple demo. And please feel free to interrupt with questions because I can't see the Hopin website. All right, so first, um, into the iOS development, really you only need a MacBook and a program called Xcode. And there are two main programming languages. One is Swift, which is newer, and the other is Objective-C, which is older. Both are equally valid. And a lot of larger companies who have like long living apps like Twitter and Google still have a lot of Objective-C in their code base, but we will be covering Swift together. We will be covering Swift today. Um, and after the intro to the programming, or just Swift, we'll go through a quick demo of a phone that might represent some of the apps you guys use on your phones. Um, and yeah, my goal is just to show you that this stuff is doable if you want to. Pretty interesting in my opinion, and very, very manageable, hopefully. An hour isn't a lot of time, but hopefully you guys will get like a high level picture of how applications go together. All right, so the format for this quick intro is I'm going to have like a brief slide and then we'll jump over to some code really quick and just flip back and forth for a bit. All right, so the first topic, constants and variables. These are really the building blocks of what we're gonna work with, like all of our programs. They associate a value with the name and a type. And a good way of thinking about constants and variables is, when you declare a constant, you will say something like var num students colon int, and this is saying I'm creating a variable with the name num students that has type int, and it just creates like a box called num students, and later on we can put ints, which are just integers, into the box. So some common types are ints for integers, strings for textual data, and bool, short for boolean, for true and false. For variables, we declare variables with the var keyword, constants with the let keyword over here. And a variable's value can change later on while a constant cannot. So for instance, this variable, which I call num students, I can set it to 20. Later, I can set it to 30. Once I set this constant max students to 50, that will always be 50. I cannot change it later. So let's take a quick look. Like I said, constants and variables associate a name with a type and a value. We saw this in the slide. We can have strings and booleans, and these are all variables. If I try to reassign, so one thing to note is that these types never change. Though the values can change, types can never change. So sum int is 1 here, it's 3 here, but for example, if I tried to change it to a string, I'm going to get an error that says cannot assign value of type string to type int. So the values can change, but the type will never change. And I'm just gonna, when the text is gray like this, that just means it's commented out. It means the program ignores it and it's just for us to look at. So constants are very similar, except we use this let instead of this var over here. Another thing you might notice is, when I declared this integer, I didn't have this colon int. And that's because Swift is actually smart enough to know, hey, 5 is an integer. So if 5 is an integer, then the thing on the left-hand side of the equal sign must also be an integer. And if you ever want to check the type, if you're doing this yourself at home, you just hold down Option, and then you can click, and it'll have this little declaration that says, the name, and then its type which is an int. Sorry, can you guys all see the text appropriately? Maybe I should have blown it up a bit. How is that? Is that a good size? Okay. Cool. And you guys can see that I switched screens, right? I'm not on my PowerPoint slide anymore.
Yeah, we can see the.
Okay. Cool. So notice if I try to change a constant's value, it'll give me an error because constants, their values can't change. So now that we know how to create constants and variables, why would we even want them? What can we do with them? Some simple operations we can do, multiplication for ints. This is called, over here, we can have 2 strings and we can add them together. So if you have a hello and a world, we can add them. It's also called string concatenation, which is basically we can just squish strings together. We can do comparisons. For instance, do we have enough money to buy the apples? And as for why we use constants and variables, it's a lot easier to work with the English rather than saying, oh, is 15 greater than 2 times 12? What is a 15? What is a 2? What is a 12? It's much easier to see, oh, do I have enough money to buy all the apples? The English is much easier to work with. All right, next up, we talked about constants and variables and their types. Next up is optionals. And optional types really just help represent the absence of a value. So an optional int has type int ? Optional strings have type string ? Optional bools have type bool ? And so on. And when an optional does not have a value, we say its value is nil. And this is this little diagram down here does a good job of showing what happens when I declare an optional type. The value is nil. I can change it later, and later on I can change it back to nil. And why do we, what is the purpose of optionals? Well, actually, let me just go over here. Why would we want optionals? Well, some operations we do in computer science can fail. For instance, let's say I have a string, and the string is 1, 2, 3. And this is a string, not an integer. But let's say I try converting it to an integer. And I do that by, wrapping the string inside this int. This int call basically converts the string to an integer. And when I do that, so we can look at the types. This has type string. But when I convert it, the converted type has type int question mark. And that's because not all strings can be converted to integers. And so, for example, 1, 2, 3, we can convert that to an integer. So we'd have 123, that's fine. The number has a value, which we can see was printed down here. But for example, if we try to convert, the string A, B, and C to an integer, that's not a number. It's not 0. It's just we can't convert it to an integer. So the value is nil. And that is why we have optionals. For the most common use cases, probably things like network connections, things you fetch over the internet. You never know if you're going to actually get something back or not. And how do we deal with optionals? While they're really good for representing failable operations, we don't actually really want to work with them that often. We generally try to convert them to a non-optional, and then we work with the non-optional, or we do something else if the value is nil. So one way of doing this, one common way of doing this is adding an exclamation mark after the optional. It's called forced unwrapping it. It's saying, hey, if you're an optional, give me your value. This operation is a little dangerous because if there is no value, then your program will crash. So one thing we will do a lot of the time is we'll say, hey, we'll create a non-optional, and then this optional number, let's just say it's an optional. We say, hey, if you're not nil, I'm going to force unwrap you and then basically put you into a non-optional. And that's a common pattern. And basically shorthand for that is this guard statement, which is basically equivalent to the left-hand side. So it's basically saying guard let, you're declaring a variable, and this variable has type non-optional, and then you say equals this optional number. And if the optional number has value nil, you will go into this else block. Otherwise, you can use a number as a non-optional. Does all of that make sense? Or are there any questions, I suppose? All right. And this is just the same thing in code. If we want to see this optional int has type int question mark, and then when we put the exclamation mark after it, the question mark goes away. It's a non-optional now. Next up, we'll talk about arrays. And arrays are a collection type that store values in an ordered list. Swift has other collection types, but we're only going to be using arrays in our application. So I'm only going to mention them here, but there are other types like sets and dictionaries, if you guys know about those. Arrays have type open bracket, the type of the element of the array, and then type close bracket. For instance, this open bracket int, that's an integer array. It can only hold integers. Same with strings, same with booleans. You can have heterogeneous arrays with like some ints, some strings, but then the type becomes more general, which we try to be as specific as possible. So what can we do with arrays? Most commonly, we just access certain values. For instance, if we have this some ints array has 4 elements, we'll go, we can do some ints at 0, and they're 0 indexed, so some ints at 1, and we can get the different values. Another very common thing we do with arrays is something called a for in loop, where the syntax is for a name, and this this value, this name, it doesn't have to be value, and then in, and then some array. So you say for value in some ints, print value. This will go through each element in the array, some ints, and it'll basically say, hey, the first value is 123. I'm going to put that value into this name, which I've also termed value. Here's a good kind of demonstration. So the first time through the loop, value will be 123, and then it'll do whatever is in these curly braces, and then it'll keep repeating for as many elements as there are in the array. Let's take a quick look. We have some ints, and we can access, it's 1, 2, 3, 3, 4, 5, some random numbers. We can access some zero indexed. At index 0, we have the first one. Index 1, we have the second one. And then when we do this for in loop, we're just printing out the int every time, and then the sum. So for example, if we wanted to take the sum of an array, we could just start at 0 and then basically loop over all the elements of the array and then say sum equals sum plus int. And then down here, you can see that the first time through the loop, int is 123, which is the first value. Sum is 0 plus 123. And then after int becomes 345, the sum is 123 plus 345, and so on. Yeah. Next up, we have functions. So instead of having the same code all over the place, we can reuse our code using functions. And functions, we have inputs, which are also called arguments or parameters, and one output, which is also called return value. And the type of a function is open parentheses, your input types, and then this arrow, and then your output type. And you can have multiple inputs, so the inputs will be comma delimited. For example, this array sum function, if we wanted to write out the sum of an array as a function, would have type open parentheses, bracket, open bracket, int, close bracket. And the way you read this is a function that takes in an integer array and returns an integer. It's going to take in an array and then give you the sum of the values in the array. And how we use a function, we say we call a function, and we just say, we just basically call the function name, open parentheses, and then we pass in the inputs. Yeah, and why would we want to do this? Let's say we had a bunch of lists of arrays. We don't want to write, if we want to take the sum of all of them, we don't want to write this code over and over again. So we can write, function that takes the sum of an array. And then computing the sum of an array is just a one-line thing. It's much easier. We just reuse our code. Easier to use, less error prone. That is functions. Last but not least, we have structs and classes. And this is really how we start building complex programs and applications. We group related constants and variables and functions into something we call a struct or a class. And how this works is we write class and then the name of the class, and then we'll have a list of constants or variables, which are the class's properties, and then some functions that can operate on these things. And then this is a special initializer. It creates an object. If you haven't had experience with object-oriented programming before, that's okay. This is just basically, this is basically just how we do object-oriented programming in a lot of languages. We'll just define a class. And how we work with this thing is this defines what the class is, but we need to actually create a class. And for instance, here I'm creating a class called Andrew class. Normally you don't have the class at the end. And then this is basically just a student class, and then I'm calling the initializer here, and I'm giving it my Andrew an ID of 2, a name, and a school string, and then I can do things with my Andrew class object. Let's take a quick look at that. So structs are also very similar to classes. In fact, they're almost identical. If I'm just going to zoom out a bit, If you look at the student struct and the student class, almost identical. They can basically do the same things. There are only a few differences, two big differences, I guess. One is that structs are value types and classes are reference types. For instance, and using student structs and student classes, very similar. The syntax is almost exactly the same. When we work with structs and classes, what does value type and reference type mean? It means when we have a struct, whenever we use that struct, pass it to a function, reassign it somewhere, we make a copy. So let's say we have an Andrew struct, I'll have ID 1, name Andrew Chen, school UCLA. I'll tell Andrew to do his homework twice. And doing your homework is really, I'm just creating a random number from 1 to 100, and then I'm adding this to a grades array. And then I'm just printing out the student did his or her homework. So if I tell the student to do this is the example I was originally going for. I have two student structs, and I set the second one equal to the first one. If I say student struct do 1, do homework, student struct 2, do homework, and I look at their grades, student struct 1 grades will only have 1 grade, which is 25, but student struct 2 will have 2 grades. So when I did this equal sign here, I basically took a copy of student struct 1, and now student struct 2 is, they're two different structs, which is an important difference from classes, where if I do the same thing but with classes, I say student class 2 equals student class 1, the student class 1 dot grades and 2 dot grades are the same. So this is the difference between structs and classes. And another big difference is inheritance or subclassing, where you can do something like this, where you say, I have a class, and this is my class name, and you have a colon, and then this is another class. And basically, when you have this colon, you're saying, this class can do everything that this class can do. The subclass can do everything the superclass can do. So my high school student can do everything a student can do, but I'm going to add some stuff. High school students have an SAT score. In addition to, my high school student can do homework. I can do everything a student can do, but I also have an SAT score. That was a very quick overview of a few things we're going to see in our demo today. I'm going to pause here. Are there questions? Anything at all that wasn't clear? I know that was very fast. Unfortunately, 1 hour is not a lot of time. All right, wow, okay, great. No questions. All right, wait, I'm just gonna check the hop in really quick. Okay, all right, we're still online. Okay, good. All right, so now next up is we're gonna use these concepts in Swift, and I'm going to do a quick demo. And what the demo is going to look like is it's gonna be in this bottom screen. We're gonna create a scrolling app with photos, and then you know what, you can tap to like it. You can double tap to like. Very simple. We're not going to do a lot of like networking. These are going to be mostly local things, but the concepts remain the same for how we model our objects and interact with them and build up our application. So that's what we're going to do next. All right. So when we build iOS applications, we use a program called Xcode. This program is actually Xcode, but it's kind of a different part of Xcode. I'm going to create a new project. So you go to File, New, and Xcode is free, by the way. New project. We're going to create a new application. And if I'm ever going too fast, please tell me to slow down. Yeah, it doesn't make sense for me to just finish the demo, but have no one understand anything. So I'm going to create a new iOS application, and I'm going to give it a product name. I'm just going to call this, it's going to be a post scroller. That's what I'm going to call it. I'll have an organization identifier. Usually this is something like a reverse DNS of your company, like com.google.whatever or whatever, but we don't really care about that right now. And then the other things we're going to leave untouched. Interface, we need storyboard. The other option is Swift UI, which is a relatively new technology that Apple has worked on that isn't super mature yet. So we're going to not use Swift UI here. Lifecycle, UI kit app delegate, the only option. And then language, as I mentioned before, there's Swift or Objective-C. We're going to be using Swift today. And so we're just going to create a new project here and then create. And give that a second. All right, this is our new project. I'm going to leave these simulators off to the side. All right, so when we create a new project, this main screen has our project details. This left-hand side over here has our file navigation, file navigator. And on the right-hand side, we have a utilities panel, which just gives us additional controls for things. And at the very top here, we see this little icon. This is our application. And then we see this little device. This is a simulator we want to run our application on. And I'm just going to run our application right now. It's just going to be an empty application, but here we booted it up and it is a blank screen. And that's kind of what we expect because we haven't done anything yet. All right, so when we start designing an application, we kind of want to have an idea of what we want to build. Thankfully, I have this little hopeful application here. So we want to build this. And how we're going to start doing this is we're basically going to break up each one of these things into something. We're going to model each of these as a class. I'm going to call this class a post. And let's just start there. So I'm going to create a new file. It's going to be a Swift file. And I'm just going to call it post. It's going to be called post. And I'm going to create a class called post. And what this class is going to do, it's going to represent one of these things. So if I think about it, what information would I need to represent this sort of thing? Well, I see four main pieces of information. One would be, the author, and I'll just keep that as a string. Another one is the image. Instead of actually having the image here, though, I'm going to have a URL where I can download the image. And I can talk a bit about that later, but we'll just go with the URL for now. And then third, I see this little heart icon. And if I did like it, it's red. If I didn't like it, it's black. So I need to know, and it can change. So I'm going to use a variable instead of a constant here. Liked by user. So is this post liked by us or not? And then finally, we had this like count, which they're all 0 right now. But in any real application, they would have a number of likes. So var likes equals 0. So those are the four main pieces of information. Did that make sense to everyone? All right, good. So this is basically where I start with my class. I'm going to actually make a little bit of a, I'm going to add a few fields. We can talk about them, but this is where I start, and you can see my fields have all of those classes. Okay, so this is going to be my class definition. As you can see, we have the author as we had before. We have our download URL to get the image. We have our likes, which is 0, and likes by user. And those were the 4 pieces of information I talked about before. The other fields we can kind of ignore for now. If we were to continue working on this application later and add new features, these fields might be useful. But we have these fields, and then we have this initializer, which will help define our class. And the initializer, you can see our 2 fields over here, likes and liked by user. We gave them default values, so we don't actually need to pass in the value in the initializer. We just need the values for all the other fields. So that is going to be what I'm displaying. This is going to represent what I'm displaying, but how will I actually get my post objects? I will create another class for that called my first post loader. This will give me some post objects to show. And normally in real applications, this thing would require a network connection, and you would go fetch, based on whatever logged in account you had, you go fetch some photos. I'm going to cheat a little here. I'm just gonna load up some photos. So I'm just gonna create a first photo loader. It's gonna do two things for me. It's gonna get the posts, get these post class that I'm gonna load up, and then it's also gonna help me get the images. Sorry, first post. All right, this is my class. And I'm just going to import this thing called UIKit, which is a framework made by Apple. And importing something means you can basically use the code that they wrote. But this first post loader, there are two functions, which first one is get post, has no inputs, and an array of posts. And this is what I'm going to show when I scroll up and down. And for now, this first iteration, I'm just going to create some random posts here in memory. And then also, what it's going to do is it's going to get an image. So I can give it a post and it'll give me an image. And how it does this is these images, I'm going to load them up locally. So also cheating a little here, but I feel like this is enough content for a separate class on its own. So how am I going to actually get the image? Oh, sorry. I'm going to load these images up in this folder called assets. These are where we can have, image assets and whatnot. I'm just going to load up some of the photos we need here. And so this class will now be able to load posts for us and get the images for us. All right. Let's just go over really quickly what we just went over. If there are any questions, please feel free. We defined a class called post, which we're going to use to represent one of these posts here. And then we define another class called a post loader, which will get a bunch of posts for us, and we'll also get the images for every post for us. And if we run our application now, nothing's going to change. It's still going to be an empty screen. We haven't actually drawn anything yet. So the next task is, now we know what we want to display. We're going to work on actually displaying it. All right. So when we look at our UI, we're going to look at something called this main.storyboard thing. And it's, if we go here, we'll see it's very simple. It just has an arrow pointing to an empty screen. And this screen is called a view controller. What this is this is our application. When our application is launched, it'll go to this screen, which is this screen, this blank screen you see here. And that's all our application does right now. And generally, view controller is the term of the class. Usually, UI view controller, one UI view controller corresponds to one screen at a time, usually. So for our purposes, we're going to create our own view controller, but it's going to be a special type of view controller, which has this sort of scrolling functionality for us that helps deal with the, basically loading up different rows. And Apple has one built in. It's very common. It's called a table view controller. So I'm going to click this plus button. And I'm just going to look up table view controller. I'm just going to click on this and drag this here. And this is going to be our main screen for our application. And all we're going to do is we're going to click this arrow. This is the initial screen that the application is launched to, and I'm going to drag this over here to this view controller, to this new screen. I'm going to delete this old one because I don't need it anymore, and now we're just going to have this one. And now if we start up our application and relaunch it, it'll look slightly different. I don't know if you guys will be able to tell. If you guys can see, there are like gray lines now. So now it has a bunch of rows, which we want, but all the rows are all empty right now because we haven't done anything yet. And we can also delete this file corresponding to that thing I just deleted. So we don't need this anymore. We can just get rid of it. All right. So first thing we're going to do is we're going to make this our own. We are going to create a class to represent this in code. We'll do file, new, file. This time we'll do, it's called a Cocoa Touch class. These are like the UI classes that Apple has made, new Cocoa Touch class. It's going to be a subclass of UI table view controller. Remember when I mentioned classes before, there was subclassing. So when we create a subclass of UI table view controller, this will be our own, but it can do everything that a UI table view controller can do. So I'm just going to create this. Apple will populate this with a bunch of things, a bunch of methods that we can implement. We don't need most of these for these application. We're just going to delete a bunch of these lines. We will keep 3 methods, which I will talk about now. So the 3 methods we're going to keep are, these methods tell the table view how to load its content, basically. The first one is number of sections in table view. And this is a function definition that might look slightly different. It's function, the name of the function, but this parameter has 2 names. And all this is this is the external name, and this is the internal name. So if I call, for example, if I call number of sections, the parameter is called in, but inside this body, the parameter is called table view. And that just makes it, I guess, easier to communicate the intention. I don't have to have really long parameter names. And what sections are is, we're just going to have one section, but if, for example, if we go to the settings application, we can see this is actually a table view. And you see how these 3 rows are grouped together? That's one section. This one is another section. This is another section, but we're just going to have one section with just photos. So that's what sections are for. We're just going to have one section. Return 1. And now this next one is table view number of rows in section. How many rows do we want in this table view? Well, we have our post loader, which gives us an array of posts, and we just want 1 row per post. So what we're going to do actually is we're going to say, we're going to go get our, we're going to get our posts from the post loader. And how many rows do I want? I want 1 row per post. Post.count. All right. And then this final one is where we actually configure the cell, where we actually say, hey, this cell should have an author and the author name is Alejandro, or this cell has 50 likes or 0 likes or whatever. We're not going to get to this yet, but that is this will basically tell us what we've done so far. Will tell us how many rows we have, and let's start setting up the UI for each cell. These are also called table view cells. And in order to do that, we go back to our storyboard. One thing I will note is this table view controller that we dragged out, it's not actually a post table view controller yet. It's still just a plain UI view controller. and we go to our utilities panel, we click this middle thing, and it says class UI table view controller here. It's a little small. I'm just going to change. Can everyone see that? I'm actually not sure how to blow up this text here. All right, post table view controller. I want to change the class to post table view controller, and that will basically signify that this thing we see here is represented by this code that we've written here. One other thing I will, one other thing I will do is I will go and change. Here we can see our table view has row heights. I'm going to say every row is just 400 pixels. You can change this however you want, but I'm just going to start with 400 and go from there. And one other minor thing is table view cells can be selected, but we're not going to have any selection. We're just going to do tabs and stuff. So I'm just going to say no selection. We can't select any cells. All right, so now let's actually set up the UI. And when we look at this, we have basically 4 pieces of UI. We have this text line, and that text line is something called a UI label. And I will actually go here, click on my table view cell, and I'll click this plus button up in the right. I've got the table view cells content view selected. I'm going to hit plus. And if I look over here, a label, UI label presents read-only text. That looks pretty good because we just want, this is editable. We just want to have some text to show the author name. And I'm just going to drag that here and boom, put it down there. And next up is this image. And we have something for that too. It's called an image view. Image view shows an image. Just gonna click that, drag that down below, and put it there. Below that, we have this thing where if we tap it, it turns red or empty or whatever. That is going to be something called a button. It'll be a special button because this button by itself, is won't look like a heart or anything. That's going to be a button. It'll be empty for now. And then after, below that, we have another label. And those are our 4 pieces of UI. And now this looks nothing like this. What we will do is we'll have to set up the UI. And the way we do that is we use something called constraints. And if you click on this element here, and you go to this bottom little icon here, I don't know how to really describe it, a little box with some lines next to it. And you click on that, you can say add new constraints. And what are we going to do? We're going to say this label should be at the top and all the way to the left, and we're going to make it stretch all the way to the right. So we just click that line there, and now it turns red. That's going to basically say, hey, I'm going to constrain you 0 pixels from the top, and now I'm going to constrain you 0 from the left. And this one is 332 because right now it's 332 away from the right, but I don't want to stretch it all the way to the right. I'm just going to say 0. And that stretches it all the way to the top, to the left, and to the right. And you can see over here that we have the constraints here. The leading is equal to our leading margin, the trailing. The leading is the left, the trailing is the right. In right to left languages like Arabic, it'll be flipped, but we don't need to worry about that. And then I'm going to put it at the top. I'm actually going to add one more. I'm just going to say, I'm going to give it a height of 30 because why not? All right, and then next up is our image view. What our image view is going to do is it's going to go all the way to the left, all the way to the right, and the top is going to be at the bottom of the label. So we're going to make it go all the way to the left, all the way to the right, change that to 0. And this little checkbox says constrained to margins. What iOS does, it'll actually have a little gap between the edge of the screen and what it calls the margins. So for the labels and text stuff, we usually want those not all the way at the edge. So I constrain those to the margins, but the image, I kind of want that to go all the way to the edges of the screen. So I won't constrain those to the margins. And I'm just going to go all the way to the left and all the way to the right. Add 2 constraints. And I will also, I'm going to click on the label. I'm going to hold down Control. And I'll click and drag from the label to the image view. And I'm going to say vertical standard spacing. I'll click that. And what that does is that basically creates a constraint. And we can see it on this left-hand panel here. Where the image view's top is equal to the label's bottom. And that's what we want. With the standard spacing, you can change this to 0 or whatever. Doesn't make too big of a difference. All right, now for the other ones, for the labels, all right, I'm just gonna do this a little quicker. I actually don't need to drag this anywhere. I'm just gonna change this to the left, to the right, and to the bottom. Label is gonna go at the bottom. This is gonna be this one down here. And I'm also gonna give it a height of just 30, just because. All right, add those constraints. This button, which is invisible for now, I'm gonna add the constraints all the way to the left. And now the button is not gonna stretch all the way across. The button is just going to be, have a height and width of 20. And I'm gonna add those constraints. And the button, I'm gonna say the button's bottom is equal to the label's top. That's what I just did there. The label.top equals button.bottom, but I'm gonna say equals 0. So the label's top is going to be right next to the button's bottom. And finally, I'm going to say the image will stretch. The image's top is currently pinned to the label. The top, I'm going to say vertical spacing. The image top is equal to, sorry, the image bottom. Where is the image bottom? Here it is, button.top equals image view.bottom. But I'm going to say it's the default spacing, standard spacing. And there we go. We have our UI kind of set up the way we want it to right now, where we have this label, where we have our image, we have a little button that's invisible currently, and then we have our other label. Are there any questions here? All right, great. So we have the UI set up, but we aren't actually like doing anything with it yet. We haven't actually like made any references to it in the code. And we're gonna do that next. We will do that. First, we're gonna create a new file. We're gonna create a file to represent this cell. File, new, file. And it'll be a Cocoa Touch class again. And these cells are called UI table view cells. So it'll be a subclass of the UI table view cell. We'll call it a post because this represents a post. We'll just create that. Delete that. We don't need any of that. And now what we're going to do is we are going to go back to the storyboard and we're going to hook this up. Well, first thing we're going to do is go to the cell. We want to go to the cell and say, remember how I did this with the table view controller? I said it was a UI table view controller and I made it my post table view controller. Well, now I want the cell to be a post table view cell. And actually, I want the button. The button's going to be a little custom class too, because it's going to be a little special. We're going to create a class for that too. It's going to be a subclass of UI button. And we're going to call it our like button class. Just create that here. We'll go back to our storyboard, click the button, and it'll be not a UI button, but a like button. All right. And how we're going to wire this up is we're going to reference this UI in the code. We're going to go to this little, these lines here kind of, and we'll say assistant. And this will open up a second editor for me. Sorry, 1 second. Whoop. This was the post table view cell. Content view. Open up the assistant. All right, no assistant results. Great, that was not supposed to happen. 1 second. All right, if anyone has questions, you guys can ask now. Let me just check something really quick. Let me just restart Xcode really quick. Sometimes the interface builder gets a little funky. I feel like it should pop up a assistant editor for me. All right, we're gonna go back to Post Scroller. All right, there we go. It loaded it up. I don't know why Xcode was misbehaving. I don't know why. All right, we are back. We're gonna go to our, and where we were is we're gonna try to hook up this UI to the code. We're gonna say, we created this post table view cell to represent our class. So we're gonna put the UI in here. And how we hook this up is we control, click, and drag, and it'll create something called an outlet, and we'll give this a name. This will be, sorry. Let me just load up the, okay, yeah, here's our little demo. This thing is gonna be the author label. I'm just gonna call it the author label, and it's of type UI label. And this image view, I'm gonna click and drag, post image view. And finally, this button, this is gonna be the like button. And finally, the label will be the like label. All right, now we have our references to this in the code. Now we can go back to the controller here, and now we can talk about this function here, where we actually create the cell. One thing a table view does for you is it reuses cells. When you scroll, it doesn't actually create one cell for everything you have. It reuses them. And that's what this function here called DQ reusable cell is. We attach an identifier to the type of cell we want. It'll go and it'll create a pool of cells, and then it'll grab one, and as it scrolls off screen, it'll return this cell back into the pool. And we first need to set up the identifier. Go back to the storyboard, and we're going to take a look at our post table view cell. Go here, identifier. This is going to be our reuse identifier. We're just going to say post cell. All right, and now in our table view controller, we will we're just going to do this, where we load up the cell with that identifier we just put, the post cell. And what are we going to do to the cell? We're only going to configure the author and the image for now, but we want it to be the post author and image, right? One post per cell. So how we get the index is this thing called an index path, which is really just a section in a row. And since we only have one section, we only need to look at the row. So we get the post we're referencing, then we change the author labels text to the post author, and then we change the post image view to the post loader's image. And let's just run that really quick and see what we get. There we go. There we go. So the like button and the like label here, we haven't configured that yet, but as you can see, we have the the author name, and then we loaded up the images, and we can see them. You can see them there. Oh wait, but this image looks a little different. We kind of want our images to fill up the whole space like this, and that's just a simple setting on an image view. It's called the content mode, and we can go to the image view here. We just click on that. The content mode aspect fit is it's going to try to fit it within the image view we give it, but maintain the same aspect ratio. Instead, we're just going to change it to aspect fill, where it'll maintain the same aspect ratio but fill the image. Are there any questions on how we've gone here so far? And this will almost get us to the end. There we go. Now we have our images. We just need to configure our like button and then our like label. So our like button here, we're just going to configure it to be a little hearts basically. And that's just going to be this code right here. This is the initializer. We just do some setup code here, nothing super crazy. And then I'm going to have one function that just sets if this button is liked or not. And also if we want the like to be animated or not, because when we tap on it, we want it to be animated. But when it's scrolling on and off screen, we don't want that to be animated. So that's what that does. We can go over this little animation code later, but basically we just set the image to an empty heart or a filled heart and then change the color. So that's the like button. Next up, we will go back to the table view controller and we're just going to configure the like button. And here we go. This is one other thing, sorry, is what happens when the like button is tapped. Well, when the like button is tapped, we want to do something. How do we know what to do when it's tapped? We're actually going to go click our button, control drag one more time. And instead of creating an outlet like I did before, I'm going to create an action. And what is this action going to be? It's going to be when we tap the like button tapped. And it's going to happen when we touch up inside the button. So this function will be called when we tap up inside. And whoop. And what we're going to do is we're actually going to create a new variable. And this variable will have type. It's going to be a function, but it'll take no inputs and it'll take no outputs. And I'm going to let the view controller tell me what to do when the like button is tapped. So I'm just going to take the like action. I'm just going to call the like action. And now in the view controller, we can say, hey, when we tap the like action, we configure it for the specific post. That specific post, we toggle the liked by user, we increment the likes, and then we can set up the like label. And let's see if this works. And now we have our hearts, and if we tap the like button, oh, yay, it turns into a red heart and whatnot. Yeah, there are a few more things we could go into, but I feel like I'm running out of time now. So I will kind of pause here. I think this is a okay ending point. We can do a quick recap, or if anyone has any questions at all, please interrupt me. I'll just do a quick recap of what we went over. First thing we did, we created our post class that was to represent what we're actually gonna, what these things are and how we're gonna draw them. Next, our post loader gives us posts to draw. Third, we went in here and then we kind of drew up the UI, and then we dragged them into this cell we created. And then fourth, and finally, we basically, we had a custom like button with some, animation code or whatever. But most of the logic was, in here, in this self arrow at index path function where we get the post and then we just configure the author labels. And this can be cleaned up, but I only have 1 minute left. So that is a high level view of how the application comes together. I hope that made some sense. I think it is very okay if not everything made sense to you. This was very fast and there was a lot of stuff that we covered, and it was really only an hour, so you shouldn't beat yourself up if it did make sense to you. I'm going to switch back to the Hopin site now and stop sharing my screen for a sec. Stop sharing. All righty. Yeah, I think we're just about at time. So
Yes, that was perfect. Thank you so much, Andrew. And I like what you said at the end. You know, it was only an hour, so if this is your first experience with like coding or programming, it's okay if you didn't get everything. But I think this was a great intro, especially if you want to try out other languages. It's nice to get started somewhere. So thank you so much. We do have one question in the Q&A. It says, how does the App Store upload process compare to the Play Store on Samsung?
Ooh, so I'm not super familiar with the upload process for the Android Play Store, but for the Apple upload process, I think you upload your application, and then one thing you need is you need to pay like $99 a year for a developer account in order to do this. But after that, Apple has a review process, and then there's something called like App Store Connect, and then they'll go through review and notify you of if you need to make any changes or not. And yeah, it's actually been a while since I've actually released an app on the App Store, but yeah, that's as far as I remember.
Everyone appreciates it, and it seems like no one had any questions, which is great.
Sure, yeah. If you have any questions or think of any questions later, feel free to email me at, I'll just type it out, andrew.c94@gmail.com. Wait, is this chat room for the whole event, or is it just for this room?
If you click on session,
okay,
in the top right, then it'll be just for this room, yeah.
Feel free to email me if you have any questions, but yeah.
Thank you. So right now, our closing speaker will be on the main stage. You can click on stage icon on the left, and that'll be an hour of closing the conference, all 3 days. Thank you again, Andrew.
All right, yep, no problem.
Bye.
Bye.